As we move on to item 2, please observe this diagram closely. It perfectly illustrates the concepts we discussed regarding energy transfer in circuits.
Item 2. The government has identified land in a certain area for establishing a nuclear power plant. As a standard procedure, the government has informed the people living in that area that they have to be relocated, since they cannot coexist with the nuclear power plant. However, majority of the people have insisted that they cannot leave their land and think they can coexist with the nuclear power plant. The government has promised that after a specific period of time, the community members will be allowed to return. Due to this, data about the activity of the radioactive materials to be used in the nuclear power plant has been provided to the people in Table 1. Count rate per minute 800, 525, 335, 215, 150. Time 1x 109 years 048 12 18. Unfortunately, none of the community members can make sense of the data. The community members also want to know if there are any benefits of radioactive materials in general. You have been contacted by the community members for help. Hint: the environment would be safe from waste radiation when the count rate falls below 35 counts per minute. Task A. Help the community members to I. Understand the need for them to be relocated as soon as possible. T. Determine the time that has to pass before they can return to settle around the power plant again. Use the data in Table 1. B. Describe any 2 benefits the community members are interested in. A. I. Need for relocation. The community members must relocate because radioactive materials, like those used in a nuclear power plant, emit invisible but highly dangerous radiation, alpha, beta, gamma. Danger: this radiation is ionizing, meaning it can damage living cells, leading to severe health problems like radiation sickness, cancer, and genetic mutations. Coexistence: it is impossible to coexist safely with active nuclear materials without extensive specialized shielding. An accident at the plant could release large amounts of radiation, making the area uninhabitable. The government is relocating them for their own safety. A. Time to return. To find the time before the community can return, we must analyze the radioactive decay data to see when the count rate falls below 35 counts per minute. We do this by plotting a graph of count rate versus time. Using the table given to us, we generate points to be plotted. We plot this graph basing on our points, which have obtained from the table given to us, and these points are represented by the red dots on our graph. When time was 0 counts per minute were 800. After 4 years counts per minute was 525. After 8 years counts per minute was 335. After plotting these points, we join them using a free hand. On the y-axis, that is count per minutes axis, we look for 35, then we draw the horizontal line till we reach the blue line. At that point, we go down and read the corresponding value that will be the required time, estimated to be approximately 29 to 30 times 10 to the power of 9 years. Now let us put this in writing. By observation or extrapolation, the time to reach 35 counts per minute will be slightly before the 5th half-life, estimated to be approximately 29 to 30 times 10 to the 9th years. For this case, we have used the graphical method. One can also use the formula. The difference is that we're using a graph. The answer you get is an estimate, but the formula gives exact answer, though both are allowed if one is not restricted. Conclusion: the community must wait for an extremely long time, approximately 29 to 30 billion years, before the area is safe to resettle. B. Benefits of radioactive materials. Medical uses, diagnosis. Radioactive tracers can be injected into a patient. A detector can then track the tracer's movement, allowing doctors to study organ function treatment, radiotherapy. High-energy radiation is focused on cancerous tumors to kill the cancer cells. Sterilization. Gamma rays are used to sterilize medical equipment like syringes and gloves, as they kill all bacteria and viruses. Industrial and agricultural uses. Industrial tracers, used to find leaks in underground pipes. A radioactive substance is added to the fluid, and detectors on the surface can find where the radiation is leaking out. Gauging, used in factories, e.g. in a paper mill, to check the thickness of materials. A source and detector are placed on opposite sides. If the material is too thick, less radiation gets through. Food preservation. Irradiating food, like fruit or meat, can kill bacteria and pests, extending its shelf life without making the food radioactive. Thank you for watching. Subscribe for more. We meet at the next video. That is item 3.